Partial fraction 7, we're going to look at some integration of case 2, and we're just going to cover one example in this video, and you remember that case 2 is repeated linear factors. So let's consider the following. We have the antiderivative of 3x plus 1 over x plus 2 all squared, hence the repeated linear factor there, dx. Okay, so using partial fractions on this, we can see that it's a case 2 because we'll have a over x plus 2, b over x plus 2 all squared, and we're going to integrate those. Alright, so progressing with our partial fractions, we'll have this, which was covered in a previous video, and we basically need to sub in x equals negative 2. So we have negative 5 equals b, so b equals negative 5. Another thing we can sub in is x equals 0, which we saw in a previous video as well, and we'll have 1. Now we're also going to sub in the value for b as well. Alright, so we have 2a plus negative 5, or 2a minus 5. So 2a equals 6, a equals 3. So we've got our parameters a and b now. So we can go back now and integrate what we set out to integrate, namely that. So subbing in a and b, we get, and splitting up the integrals as a sum of two integrals, we've got 3 over x plus 2, so the integral of that, and because b is a negative, we could say it's minus the integral of 5 over x plus 2 all squared, following case 2. dx. Okay, so here's where we do a bit of tinkering here. Because we're going to get one of those results with natural log on that one. So we've set that up for success. We can bring the 5 out here. And then we've got 1 over x plus 2, but it's all squared, so it's not a straight situation. What I'm going to do first is I'm going to use a negative index just to make it a little bit easier to see what I'm doing. Okay, so we could say it's the integral of x plus 2 all to the power negative 2. Eliminate the fraction. I hope you do appreciate why we can't just use the natural log process. Okay, there's a function of a function there, and it doesn't quite fit the f dash of x over f of x type integral either. So what we could do is use a simple integration by substitution strategy here, and it is only a simple one, and it's good because we need to keep that fresh to that process. So we have an integration by substitution in the middle of this. So I'm going to do a u substitution, and where should I write that? Just here. Where u equals x plus 2. Therefore du dx would be 1. Or more usefully, du is the same as 1 dx, or just dx. So du is the same as dx. So if we sub in u, we have u to the negative 2. And instead of dx, we have du. Alright, so now we're looking better, and it was a simple u substitution. Let us integrate. So we have equals 3 natural log x plus 2 minus 5. Now, so if we integrate with respect to u here, we have to raise the power by 1 divided by that same value there, so that'll be u to the negative 1 divided by negative 1, so that would be like putting a negative 5 there, and u to the negative 1 plus c, and first term's the same, minus negative is a plus, 5 times 1 over u using index laws, some constant, okay, nearly finished, and that could be written as 5 over u, but I'm going to write it actually as 5 over and substitute back in terms of x, 5 over x plus 2 plus c. So there's a case 2, and once we got the partial fraction sorted, we had a natural log type integral and also a simple u substitution process there.